Okay, this is the last part of our review for the Molecules to Atom Unit 1 Physical Science test, and in this part we're going to talk about classifying matter. And some key things to remember are there are two main categories that we can divide all matter into: pure substances and mixtures. These categories can be broken down more specifically. However, a pure substance cannot be a mixture or vice versa. It's kind of like a cat can't be a dog. They all belong to the animal kingdom, but they're not interchangeable. All right, so we've seen this table several times before. We start with matter. We take a look at the matter and we look at the composition of that, and we classify it as either pure substance or mixture, and then we can further subdivide these into element, compound, homogeneous, and heterogeneous mixture. And what this gives you is sort of an atomic level view, and we talked about this in class. I used sort of element symbols for some of these. So matter is something that takes up, has mass and takes up space. That's a general definition. Goes back to our first semester. All matter can be categorized into these two groups. We'll start with the pure substance. That is matter which has a fixed or uniform composition. We take a sample of it, and every time we take a sample, we're going to see exactly the same stuff. And you can see that in each of these pictures. It doesn't matter how I take a look, I'm going to see exactly the same composition of things. In an element, we're going to see all the same type of atom. And truly our periodic table is a list of that. So if you get an element symbol, pure gold, pure silver, pure aluminum, those kind of things, we're going to get all one type of atom. We can find those elements right on our periodic table. A compound has two or more atoms bound together in fixed or uniform matter. And I've said to you, one of the things you're going to look for as your clue is a chemical formula. And looking at this, you have one gray atom and two red atoms. This actually looks like our carbon dioxide molecule that we had built compounds of, molecular models of. So we're looking for that chemical formula. That's going to be a clue to you that it's a compound. They're bound together. Every time I take a sample, I'm going to get the same number of carbon atoms to the same number of oxygen atoms, the same ratio. It's a fixed ratio. That's not going to change. Okay, the other category are mixtures. So if it's not a pure substance, if we don't have that fixed or uniform composition, then I have a mixture, and that's two or more substances combined together. For example, we had given you air, which is nitrogen and hydrogen and oxygen, and there's some water molecules, there's some carbon dioxide molecules. They're not bound together per se, it's all just kind of out there floating together. We can't see the difference between the different particles, but it's all out there. I don't have a chemical formula for air. It doesn't exist. Okay, so we have two different types: homogeneous mixture. This is a mixture, two or more substances combined together that I can't see the parts. Air is a good example. I can't tell the hydrogen from the oxygen just by looking at it. Other examples include dissolving salt in water. I can't see the salt or the water molecules. They're just kind of in there combined. Fruit punch is another example, especially if it doesn't have pulp. I can't tell the syrup from the dye, from the sugar, from the water. I can't tell. It's all mixed in there. If it has pulp in it, then it becomes a heterogeneous mixture. So I want to keep this example as homogeneous, so we're just going to say it doesn't have pulp. Fog is another example. I can't tell the water molecules individually from the air. It's just sort of all looks white and cloudy. If I mixed white table sugar and white table salt, I wouldn't be able to tell the difference between those in general. I know some of you were concerned about crystal size, but if I ground them all the same, I wouldn't be able to tell the difference. The other type is a heterogeneous mixture, and this is when I have two or more substances combined together, and I can see the difference between the parts. Maybe not all of the parts, but I can tell at least some of the parts. And examples of this we've given are salt and pepper mixed together. I can definitely tell the difference between those. Or sugar and dirt, or chunky salad dressing like Italian salad dressing. That stuff, you can see all the spices in it. So these are our categories. We can subdivide them a little bit more finely. So if you're looking at where some of our other information fits, if we look on the pure substance side and go into our elements, it depends on how we want to categorize them, but we've categorized our elements on our periodic table into metals, nonmetals, and metalloids. And I've given some examples here. If I wanted to go further and subdivide my metals, some metals are solid at room temperature, some are liquids. That's one way of categorizing them. Our nonmetals, we have our unreactive gases in group 8A, those noble gases, and then you have your reactive gases, which would be kind of the other category, and there may be something I'm missing here, so I've put an other category in there. Metalloids, that's those elements that hit the staircase: boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. These are the ones that have both metal and non-metal properties. They're kind of that little small group of unique guys. And then on the compound side, we haven't talked about these three categories. We'll talk about these later in the semester when we deal with bonding. We have ionic compounds, covalent compounds, and there are actually polar covalent compounds, but these aren't as important for you to understand at this point. The rest of this table we have covered, and I do expect that you'll know it. We can look at the mixture side, and under the mixtures, we can look at homogeneous mixtures. Remember this idea that I can't tell the parts. It's two or more substances together, but I can't tell the parts. So we have solid homogeneous mixtures. Those were examples like baking powder and baking soda. They're both white powders, or talc, all white fine powders. I can't tell the difference between them. Table salt and table sugar, crystals, white or clear crystals. Again, I can't tell the difference. So if I mix those together, I'd have two substances. They're mixed together. I don't have a chemical compound for the substance as a whole, right? But I can't look and sort of easily pick out the salt crystal from the sugar crystal, or a baking powder flake from a baking soda flake. I also have liquid homogeneous mixtures, and those can be broken down into solutions and colloids. And solutions, these are done by particle size. Solutions, the particle size is really, really small. These are usually dissolved into something, and I can't separate them by physical means. So examples are salt and water, and the fruit punch, again, without pulp. Those are examples of solutions. Colloids have a larger particle size. They actually will block light on the solutions. We can usually get light to pass through them pretty easily. On colloids, they're going to reflect some of the light. Milk is an example. I can't tell the milk fat from the water, but if I try to shine a flashlight through it, it's not going to work very well. Fog is another example. I can't pick out necessarily that air molecule or component of the air, the hydrogen, the oxygen, the carbon dioxide, from the water molecules. On an especially foggy day, it's just going to kind of look white. I shine a flashlight, and I get a lot of glare back. That's one of the reasons you have fog lights on your car. They are aimed differently so that you can actually see the road, because if I shine my lights into the fog, I just get a lot of glare back. Heterogeneous mixtures, we can do the same thing. Solid heterogeneous mixtures would be examples like mixed nuts or trail mix, salt and pepper. Things that solids mixed together, two or more substances mixed together, that I can actually determine one part from another easily. Liquid heterogeneous mixtures would include suspensions. Suspensions are like that Italian dressing, where I can see the flakes of the different types of seasonings. Now, one of the things with suspensions is that if I let it sit, it'll sort of settle out into its parts. So, and if we let most Italian dressings settle out, you'll see an oil, a vinegar layer, and then the seasonings fall to the bottom. That's why they have shake well on the label. Now, some of them are mixed specially to avoid that settling process, but most of them will settle out with time, and that's why they say shake well on the bottle. The other type of liquid heterogeneous mixtures that don't necessarily fall into suspensions easily would be that example of ranch dressing, where it pretty much stays mixed. We don't really have to shake that ranch dressing necessarily, but we can tell the flakes of herbs from the creamy other stuff. Another example might be blue cheese dressing, where we can see the lumps, or orange juice or fruit punch with pulp, that we can see sort of the juice and then we can see the flakes of the pulp. That would be an example. That some of those, the fruit punch could settle out with time, so that would be a suspension if it does. If it doesn't, it would go just over here under a liquid homogeneous. Again, remember this example over here has no pulp in it. It's got to be that clear fruit punch. Okay, let's practice. So here I've given you some examples. Baby shampoo, rubbing alcohol, also called isopropyl alcohol, table salt, table sugar, syrup, concrete, and nuts. And at this point, it would be a good idea to pause the video and take a look at these on your own. I'm not going to pause for the sake of time. I'm just going to go ahead through the answers. Let's see if you agree. Okay, so shampoo is a homogeneous mixture. It's likely a solution. I can shine light through it easily, but it's got different chemicals in there. Rubbing alcohol, you can see we've put the chemical formula here for you. It's a compound. Table salt is also a compound. You can see the chemical formula here. That's your clue. Baking sugar is your chemical compound, and we've shown you that molecule in class. The model is up on the side of the lab. Syrup. Syrup is a homogeneous mixture. We can't tell the parts from the whole, and it's got all kinds of stuff in there, sugar and water, and I can't tell the difference between the pieces. Concrete. Concrete is a heterogeneous mixture. You can see those rocks, and heaven only knows what else is in here from the gray stuff that binds it together. And trail mix. That's a heterogeneous mixture. We can easily pick out the fruit from the nuts and the candy. All right, let's try some more. Milk, fog, Italian dressing, tea, ranch or blue cheese dressing, and pure gold. Again, I would recommend that you pause the video here, and when you're ready for the answers, unpause it, but I'm going to go ahead forward. Okay, so milk is a, oopsie, these got out of order. Milk is number one. It's a homogeneous mixture. It's a colloid. There we go. And fog is also a homogeneous mixture, a colloid. We can't shine light through it easily. You can see that in both of those photos. Number three, heterogeneous mixture. It's a suspension. You can see all the little herbs and spices here. You can see it settling out into pieces. Ranch dressing, heterogeneous mixture. In this case, it's not a suspension. You could tell the herbs and stuff. In blue cheese dressing, you can usually tell the chunks of blue cheese from the other stuff, but it doesn't necessarily settle out over time. It depends on the brand, but it wouldn't necessarily qualify as a suspension. Again, shake well is a good example that it is a suspension. Tea. Well, tea is a homogeneous mixture. We can't tell the tea colors from the sugar, from the water. We can't tell. We can shine light through it. It's a solution. And pure gold. Pure gold. There's that element symbol. We know that we can find it on the periodic table. Okay, so that's some practice. Continue practicing.